Alright, in this video we're going to be looking at elements, compounds, and mixtures and learning how to classify substances into one of these three categories. Alright, so first we're going to look at elements. And an element is a chemical substance that cannot be chemically broken down to any simpler substance. And if you look at the picture we have below, all of the little circles are the same color, meaning that all of those down there are all the same type of atom, which lets us know that we do in fact have an element. And then we're going to be looking at compounds, and a compound is a substance that contains two or more chemically bonded elements. And so if you look at the picture we have down below, we now have two different colors of circles. So that lets us know that we have two different types of atoms, and meaning two different types of elements. And if you look how the circles are right next to each other, that means that they are chemically bonded together. And then lastly, if you look, we have two orange dots for every one gray dot, meaning that we do have a fixed proportion of elements to one another. And then we're going to be looking at mixtures. A mixture is made up of two or more substances, and you can have any sort of combination of elements and compounds in a mixture. And these are all physically not chemically mixed together, meaning that they are not chemically bonded together. And if you look at the picture we have below, we now have, it looks like a combination of different elements, different compounds, but if you look, they are not touching, they are not chemically bound together. And then that means since they're not chemically bound together, they are not in any sort of fixed ratio. You can have any amount of compounds compared to any amount of elements. And then in a mixture, each substance within the mixture does maintain its chemical identity, meaning each element and each compound in there keeps its respective melting points, boiling points. Unlike when you have several elements going into a compound, those now assume a new melting point and boiling point. All right, and taking that a step further, we're going to look at the two different types of mixtures, which are homogeneous mixtures and heterogeneous mixtures. And the first one, homogeneous, meaning the same, means that we have a uniform composition throughout, and looking at it just with the naked eye, it looks the same. The appearance looks the same throughout. And so if you look at the picture we have here, it's a glass of soda. So any spoonful or any sip you're going to take of that soda is going to be exactly the same as the one before and after it, meaning that we do have a uniform composition. And then next is heterogeneous mixture, hetero meaning different. And in those, we do not have a uniform composition, and you can physically see the different, parts throughout it. And as you can see in the picture of the snack mix we have below, you can see the different pieces of food in there. And if you take one handful, it's not going to be identical to the one after it. You could have more pretzels in the first one, or more Chex Mix, or I guess Chex, I should say, in the second one. And then also, very common in heterogeneous mixtures is you can actually have different phases of substances, such as you can have a liquid with some solids in it, and things like that. All right, and then next, this is a flow chart that you can use to kind of help aid you in solving questions where you're asked to classify a substance as either a compound, mixture, or element. So the first question, looking at the top left, that you're going to want to ask yourself is, does the substance only have one kind of atom? If the answer to this is yes, then we already know right away you can't break this down any further, meaning we have an element. But if you answer no, then the next question you're going to want to ask yourself is, can the substance be physically separated? If you cannot physically separate it, then you know that we're going to have a compound, because there are chemical bonds there which you cannot break with any physical means. But if you answer yes, on the other hand, then you know that we have a mixture. although we need to figure out if it's a homogeneous or heterogeneous mixture. And to do that, you're going to want to ask yourself if you have a uniform composition throughout. And if you answer yes, then you know we have a homogeneous mixture. And if you answer no, you know we have a heterogeneous mixture. All right, and then lastly, I just have some example problems that we can go ahead and work through. And the first one that we have to classify is nitrogen gas. And here I have a picture of it, and you can see that we have two atoms, and since they're the same color, you know that they are the same type of atom. So we already know that this is an element. And then the next problem we have here is carbon dioxide, which I also have a picture there for. And on this one, we can see we have two different colors of circles, meaning we have two different types of atoms and two different types of elements. Although we can see that they are in a fixed ratio, it looks like for every carbon atom, we have two oxygen atoms, and they are chemically bonded together. So now we know that we have a compound. And then the next problem is we have a bowl of cereal. And this one, looking at it, we already know that the cereal itself is made up of several different ingredients. So we know it is not an element or a compound. And so we already know that it is a mixture. And now we just have to decide if it is a heterogeneous mixture or a homogeneous mixture. And looking at it, you can physically see that you can tell the cereal apart from the milk. So you know that this is not uniform throughout, so we can go ahead and classify this as a heterogeneous mixture. And the last one I have is a little bit trickier. It is tap water. So we all know that water's chemical formula is H2O, meaning that we have two hydrogen atoms for every one oxygen atom. And H2O itself is a compound, and it does have a fixed ratio. Although in tap water, we do not have pure H2O, we also have added in minerals that help with taste. So that would actually make water itself a mixture. And then if we had to classify it as either heterogeneous or homogeneous, we would have to look at if we were to take a little bit of water from the tap and put it in a cup, and if we were to take more and put it in a separate cup, is that water exactly, does it look the same? Does it taste the same? And the answer should be yes, meaning we would have a homogeneous mixture.